Got the feeling in your bones, make you feel right at home. Honey, does it well.
Hello dear friends and welcome back to the High-End Society. Today we're in the heart of the Ruhr area in the city of Essen, visiting the company Fink Audio Consulting. You may have heard the name Karl-Heinz Fink before, because he's a leading expert in loudspeaker design. And anyone who's been to the high end has almost certainly listened to one of his loudspeakers before. Let's take a direct look at what's behind it all. Come with me.
Rise above the clouds and see.
Hello, Karl-Heinz.
Hello, Jürgen. It's great that you're here.
Great, thanks for the invitation.
Let's head to the listening room.
With pleasure. Karl-Heinz, thank you so much for letting us be here in your listening room. What I'm first interested in, of course, is that you've been around for a long time. How did it actually start?
Oh boy, that was roughly around the year 1980, and it was a matter of pure coincidence. Back then, I was searching for a small retail shop. I wanted to buy some hi-fi gear. I could not find the right shop and ended up at the Audio Forum in Duisburg. And I was about to buy a loudspeaker, but since DIY was very popular back then, I talked to Alfred Rudolph. I said, "What do you think about me building it myself?" And he said, "Great, good idea," and sold me the chassis. And that's how it all began.
Wow.
So that's more or less when I started to build really intensively. A huge transmission line. And I have to say I had a lot of fun doing it. And then after, well, maybe about 2 years, quite unexpectedly by chance, at Rolf Gemein's, at a vernissage event, I met a man named Rainer Römer. He really wanted to open a loudspeaker store in Duisburg. And then the idea came up, why don't you do it? Yes, and that was the beginning.
So tell me, did you actually build a professional loudspeaker workshop entirely out of your long-time personal hobby?
Well, by my professional background, I'm a geodesist or a land surveyor, you could say. I actually still find myself doing a lot of measuring these days. So I just said back then that I didn't want to spend the rest of my life in some kind of civil servant job. Well, that is how I more or less stumbled into that particular line of work. And I did that for, I think, about 2 years or something like that. It was okay for a while, but I eventually realized that I really wanted to do my own thing. And so I more or less established and founded my own company within the DIY sector. I ran it for many years, also developing various products, and I wrote a lot of content for LRAD and Elector. And back at that time, we had Yamaha as a client.
You've built for a lot of brands. Who else can you name? What exciting projects were there that you're allowed to mention?
Oh, there are quite a few others that became well known later on. You see, we were in England quite a lot. I worked with Naim, and for Naim for many years. He worked for many years at Tannoy, then moved to Mordaunt Short, spent time at Mission, and later on he contributed to Q Acoustics. I don't know, did I forget one? Castle, not to forget, that was also a great time. And in Japan, it wasn't just Yamaha, but above all Marantz, and later also Denon. We even did a project for Pioneer once. So those particular companies, let's say, are well known for the specific work we do for them. In the hi-fi sector, we've recently been collaborating extensively with Sonoro. Sonoro is actually a very interesting company for us because they come from a different background. And they actually come from the, well, let's say the traditional radio sector. But they are very committed. They have great design. And they are truly wonderful and very nice people. And then, on the other hand, we can look at the example of Peak in Denmark, where the company Peak is currently managed and overseen by Winfried Ehrenholz. That's very pleasant for us, because you have someone on the other side who actually knows very well what he's doing, and we manage the entire technical groundwork for the project.
How should I imagine it when a company contacts your company to develop or build a loudspeaker? How does that work? How does it happen?
Well, I think we've been around for so long now that many companies actually know us. And if someone really has a project, it usually starts with first considering in principle exactly what you want to do. So we don't do isolated one of individual projects where someone simply says, please make me a loudspeaker. It absolutely has to fit in somewhere. Well, personally, I have to say I really like to work with people whom I find personally pleasant and easy to collaborate with. And it also has to perfectly align with our specific methodology and philosophy of developing loudspeakers. So as a professional development company, we have to try to deeply understand and absorb the unique essence and culture of the company we're developing for, more or less.
To transport the DNA?
Yes, the corporate culture, I always say, because it makes no sense for us to build the same loudspeakers everywhere and they all sound the same.
Is there a Fink sound?
Yes, there is in a certain way, but we do not always consistently try to produce exactly the same sound. We basically work as a team here. That means there are always different people listening who all have their own areas of focus. And of course, we also try to carefully incorporate the customer's business philosophy into our considerations.
A very important question. I'm actually interested in how much of a share this company DNA or the customer's wish, how much of a share can that ultimately have in the final product, and how much, let's say, right of determination do you or your team take so that it can ultimately bear your name, your stamp, your seal?
Yes, there is a limit. So there is a specific and flexible range of tolerance. Consequently, I have to say that we rarely have problems finding a common tuning afterwards, but they are sometimes quite different from one another.
Now we're almost at the finished loudspeaker product at the listening test, but a lot of other things happen before that. A cabinet has to be developed and built, and the right choice of parts and components has to be found. How does that work here?
Well, as a rule, you really should complete the entire design beforehand, specifically the aesthetic and cosmetic design phase. Because it used to be that you took a loudspeaker and then calculated the cabinet. Today, you do it by dimensioning the cabinet exactly the way you want it, and then simply developing the loudspeaker into it. So that approach works quite effectively. We've been doing chassis development for I don't know how many years now. So it's not a significant problem at all, more or less, within certain specific limits to develop a chassis into it. The same principle also applies directly to the cabinets themselves, especially in terms of their overall design. So for many years, we've been doing a lot of detailed simulations, especially when it comes to cabinets, and also extensive measurements with the laser, so that more or less what the cabinet radiates doesn't interfere further or is as small as humanly possible. These are all things that you really do in advance. And that is also fundamentally and substantially different today than it used to be. So let's say you have a scale from 0 to 100, the maximum, then the last 10 are very, very difficult. But in the past, you might have gotten 50% on the first try. Today, we might be at 70 or 80. Yes, that means in terms of technology, simulation and measurement technology, we can already prepare a great deal. But the concept has to be in place first.
Now you have largely implemented the order. Now it's about the critical process of procuring the components, the right parts for the crossover, and the right chassis for the finished loudspeaker. Do you always work with the same long-term partners, or do you have a diverse range of different suppliers?
Nowadays, I have to say, we have one supplier with whom we have a very trustful working relationship. But depending on the customer and depending on the project, it can certainly be a different supplier. So that's not always a given. I just prefer to have suppliers that we know well.
Does the specific client typically define the bill of materials? Or are you the one who ultimately determines, okay, I simply need a certain budget to be able to deliver a decent job?
So before you begin discussing in detail more or less about the bill of materials, you have to carefully consider the final sales price in mind, along with the comprehensive financial calculations like via distribution structures and, yes, more or less what the total estimated purchasing costs will be. And from this specific amount, we then try more or less to get the most ideal and optimum result possible. So that's simply the way that it works in this field. Sometimes it can be much more important to use a better capacitor and maybe a smaller tweeter than, I don't know, the giant tweeter or the great tweeter with a very poor quality and inefficient capacitor in front of it. So you always have to carefully evaluate and assess that situation on a case-by-case basis. And yes, that is then also exactly what is so important later during the tuning process.
Let's get back to exactly that point. We've reached the point where the first sample product shows up here in the listening room. Almost 70% of the enclosure, as we just learned, is already finished. How does the work continue here in the listening room? How much is measured? How much is listened to?
Well, we measure a lot, I have to say. So we also use the measurement to make sure that we don't more or less go astray when listening. So in the past, when we didn't have so much simulation and measurement technology, people would often change the crossover here and there. And it also sounded better. But afterwards, you built a current sink that caused every amplifier to shut down. You don't do that anymore today. So today you measure, you listen, and if you make a change, you make the change, but you check in the simulation to see if the change is okay. But for us, listening is ultimately the part that is most important, because everything else is just preparation for listening. It is true that you think beforehand, for example, about how to design the bass tuning. There are people who say, oh, in an anechoic chamber down to 20 hertz. If you put that in a normal room, it just drones and booms, because you have the modes in every room. You have the floor, you have a ceiling, you are somehow at the back wall. So we try from the outset to let the speaker, when you measure it in the anechoic chamber, really drop off slightly towards the bottom, because together with what you get back from the room, you then have a reasonable reproduction, hopefully. We also have that actually captured in the simulation in such a way that I have a correction filter. That means I switch it on in the simulation and can then create a flat frequency response, because otherwise it's always incredibly difficult to see if that's the right slope yet. You can do that very nicely, and it usually works quite well. So from that point of view, we definitely focus on the listening, of course.
Yeah. You just mentioned the flat frequency response. That certainly looks absolutely magnificent in some test reports with the ruler flat frequency response. But is it truly enjoyable and engaging to listen to a loudspeaker like that? Or isn't it possible that some other things are significantly more fascinating and exciting when listening to music?
No, well, I do think you should have a flat frequency response. You just have to see what it's like off axis. Because a tweeter that, let's say, drops off sharply off axis, you make it a bit louder on axis to compensate for that. You always look very closely at the range between 1.5 and 3 kilohertz, because that's where our ear is particularly sensitive. And you tune the loudspeaker so that the largest possible number of recordings sounds good. Because what good is it to me if I have something that's ruler flat, but I only find one track on which it sounds good, and everything else makes my ears bleed? Nobody gets anything out of that.
What music do you work with and listen to?
You have to make a distinction there. So there's music that you work with. That's always the same. No, it's not Kiss Don't Go or Hotel California either. So I don't use those. But there are other pieces that you know very well, where you know where the voice has to be, how high it has to be, how wide it can be. It can be in this position here and there. Or timing, for example, bass lines, do they play together? Yes, you always use the same pieces for that. But of course, you don't listen to them in the evening after work, because that's when you listen to your own music. And that's not very important, because I always say the product gets better when you have time to live with it. So I always notice that a loudspeaker is starting to get good when I feel like staying longer in the evening. That means I usually play a favorite record and then listen closely to my music. That's then jazz or blues or sometimes even classical music, but not so often. When I really start to enjoy it, then I notice the loudspeaker is finally getting to where it should actually be. But you have to take the time to live with it. So just finishing it, listening to it once and saying, yep, the voice is where it should be, is actually not enough. And that might also be what makes the difference between normal hi-fi and real high-end. How often can I start over? How often can I vary the concept again? Do I have the time for it?
Yes, and that's certainly also a piece of passion that has gone into the product by now. And to tear that apart again, at least in part, doesn't that hurt?
No, I mean, that intense burning passion is exactly what makes you tear it all apart again, that you say, can it be a little bit better? Can you get more out of it? Or sometimes you have an idea. I've experienced waking up at night and having an idea. Then I got dressed and drove there. It doesn't happen as often as before, but it still occurs, because then you might say, you could try that, and frequently that works too. But the process is like this. We listen and then put the thing away for a while, and after a bit we take it out again. And if I find I still like it then we've reached a very good point. But the truth is, it's torture. It is in some ways torture. You almost have to have a masochistic personality trait, because you always have doubts. But my goodness, I mean, so many truly exceptional and high-quality products were originally developed by talented people who just worked in that specific way. I personally worked closely with Ken Ishiwata for many decades, and that remarkable man truly had it. He possessed that deep, burning passion, and he tirelessly tried again and again, constantly doing something else and trying once more here and there until it was perfect.
Passion, of course, also has to do with the fact that at some point you no longer just do contract work, but want to do your own thing. For you, this manifested itself in the fact that you can now call a classic and historic English brand your own Epos. What exactly was it that led you to that?
I knew Epos from a very long time ago, from the earliest days of the industry. I also knew Robin Marshall, who was the original person who founded the company. The brand then belonged to Mike Creek, who I also know quite well. And back then, Mike wanted to downsize a bit, more or less. He's also getting on in years. And that's how we got to talking. And my export employee at the time, David Jeffries, who has unfortunately since passed away, was originally an old Epos man. And that is precisely the way in which this connection came about. What is quite interesting is that I didn't necessarily want to have a brand that was, let's say, so strictly tied to a specific technology, because I don't just want to build some kind of nostalgic retro-style box that's then exactly the same as the old one. What for? But I also can't just throw away what I've learned in the 40 years since then. And if things can be done differently and better today, then I'll do them. But I also took a lot of flack from the old Epos fans who said, you cannot possibly do that, Naim. And it has to have just one capacitor and absolutely no crossover. But thankfully, that has significantly improved in the meantime. And most people now understand that I didn't just fall on my head.
What's next?
Well, there will certainly be a bigger one. I mean, I'm a big fan of affordable hi-fi. That's why we'll also make something smaller price-wise. But to completely keep my hands off the expensive, well, the high-end stuff, whether it's expensive is another question. I can't do that either. I already have an idea for something, and we're in the process of simulating the basics for it, because there are a few things that are a bit new. There will be something coming, and also at the lower end of the range.
So, for my final question, what do you truly enjoy the most? Small, affordable hi-fi, or being able to really let loose and push the limits, really going all the way to the top?
Oh dear, always the thing you have right now, then you want something else. No, personally, I find it very interesting to see what you can actually achieve on a very small budget. I mean, we currently have a significant problem with bringing in new people into our industry, because even a 5,000 euro system, which is sort of the gateway drug for enthusiasts, is still a whole lot of money for many people today. And I think it can be done on a smaller scale, and we will, if possible, continue to work hard on that. I have worked on a wide variety of different budget-friendly brands over the years. Mission, Tannoy back then, the Mercury series, but also back at ALR. We did a lot of entry-level audio equipment and products. Q Acoustics was basically, in principle, constructed and developed based on the speakers of the then bankrupt Mission. So I really have an immense amount of genuine fun with that. And I find there's a lot of interesting electronics from China for very little money. But with the loudspeakers, they haven't quite figured that out yet, and that's a good thing.
Well, and that's what the Fink team is for.
Yes.
And let's take a look at exactly how that's done.
So, and here we have our design and engineering department. Mo?
Good day to you.
Mo is basically responsible for everything related to design, drawings, and CAD. But he also does many other things in the field of acoustics now. But this is, let's say, his current main focus. So here, for example, is an ES28. So before we even do anything like picking up a piece of wood, it's more or less completely designed.
That means regarding internal cabinet bracing or various damping material and the crossover positioning, you simulate every one of those aspects right here in the computer system first.
Well, regarding the damping material, yes, basically we do. I mean, minor adjustments and fine-tuning are still made afterwards once you actually listen to the final output. But especially the braces where the stiffening goes in, that's more or less completely and meticulously designed and simulated on the computer screen and dimensioned.
Now I see an extremely long bass reflex port here that goes downwards.
Well, one of the rather problematic things is the standing wave inside the cabinet.
Yes.
If you want to completely eliminate that, the port can basically only go to the middle. But the maximum output of a port depends on its diameter. If I were to put it at the back now, and I could only go to the middle, then I'd only have this much, and it could only be this big. If I want a large port and still want it in the middle, exactly where the critical standing wave is, I place it downwards and have a large diameter at the same time. By approaching it in that way, I can efficiently accomplish several objectives simultaneously.
Good solution.
It's just that everything is simulated. I mean, up there in the cabinet, there's a hatch in the back. That means the crossover itself sits more or less at the top in a sealed compartment, so it's not constantly shouted at by the speakers.
Yeah.
You won't see much of that later when the speaker is finished, but there's a great deal of thought and effort put into it. And it's all simulated and calculated beforehand, and more or less optimized in terms of the overall design. Because let's be honest, who's going to make 10 different prototype cabinets? You can also see these two-layer structures here in the outer cabinets. That means we're building more or less 2 layers with a damping layer in between. Yes, I mean, cabinets are a part of a loudspeaker that shouldn't be underestimated. Many people talk about drivers, and in general, the cabinet is actually almost the most important thing alongside the crossover. And in my opinion, far too little is still being done there because there are people who use this brute force method, but they do it with an enormous amount of effort. And we try to get a good result, but also to keep it affordable.
Now I see a record player here on the other screen as well. I mean, that's also one of the tasks you have to handle. You're not just involved with speakers, but also with electronics. And as I see with record players, what kind of project is that?
Yeah, a record player is always kind of a fun object because we also have mechanics that move. So actually not that far away from speakers. And we're working a lot for Sonoro now. And Sonoro wanted a record player, and they already have a record player. They wanted to make a new one. And then I said to them, yeah, let's join in. We are going to have a lot of fun with it. And so quite a few different components and features on the record player have been changed compared to the original design that we first started with.
And are there just the two of you working here in the CAD department? Or are there other people working on it as well?
Well, we have in total, we have our new guy, Mac, now. He's new, but he's only been here since Monday, so he can't contribute all that much yet. We have a third one, so we actually have a fourth one. There is Marcus, but he only works for us on a part-time basis now. Nico is not actually based here, though, but in Ulm. That's why he's not here. But basically all our console and simulation technology has more or less moved to Ulm because it wasn't possible to find people here on site who could do this area. It's hard to get people from the university. They usually have no experience. And Nico has just finished a degree program that focused solely on console, so we're really highly specialized there. And there will be many more interesting things to come in the future. We have 2 or 3 things going on. This includes, for example, the use of a high-performance air motion transformer, completely defined in simulation software, because that hasn't existed like that before. Nothing on this thing is more or less rotationally symmetrical, so it's incredibly difficult and takes a very long time. And that was his master's thesis. We've already learned a lot because you can suddenly see what happens in such an air motion transformer. I can't even scan it because the front plate is always more or less in front of it. There's only 1 degree program in Le Mans. where electroacoustics is taught. Otherwise, I wouldn't know. Maybe somewhere in Dresden with Professor Klippel.
Speaking of klippel, I know you have a measuring station from them.
Yes.
Shall we go look at it?
Then let's just go over there.
Great.
Thank you. Now we're coming to our professional klippel room.
Very impressive.
Yes, we've been klippel users from the very beginning. So I started with it very early on. Recently, a new version of the software was released, which also produces results faster and actually more reliably than classic measurements. And when a chassis like this comes to us, it first has to go on the test bench here, and then we take a look at what's going on with it.
What all can I see here now?
Well, the three classic things you look at are more or less, what is the driving force over the excursion when it moves? What is the stiffness of the suspension when it moves? And what is the inductance of the voice coil? Most people, well, there are still manufacturers who don't build in any compensation, which I can't understand at all because that makes the biggest difference in sound. Here in this example, you can see that the BL range is very linear. I mean, it's only plus or minus 1 millimeter. In this area, you can already see that the loudspeaker becomes very stiff as it moves in. So you can see the change in stiffness, and that just doesn't match up at all.
Ultimately, these two parameters are not correct as they are.
Yeah, not like that. No, you would make these a little bit flatter here. Yes, you can see here that there is an asymmetry in there. You would actually need to make this section a bit flatter right here. Yes, you can clearly see that there's an asymmetry here. And with that observation, we can now say, look, a different geometry is required here, and then it will also fit much better. After that, it's basically about analyzing the membrane itself or even the entire loudspeaker system, and then you can see afterwards which part moves how. But if you go even further, then the loudspeaker starts to look a bit different. So this typical story, yes, that it has to be piston-like and stiff and light and something else, well, that's actually a lot of fairy tales and common folklore. Because a membrane must have a specific weight to produce a certain bass in a certain enclosure and magnet system. If you make it light, you don't get any bass.
Exactly, yes.
Yes, but you can already see here that, well, at different frequencies, quite unusual things actually happen. You can also see it as a cross-section. Right there, you can see it is really quite funny. And then up here, it gets completely and utterly chaotic. So it's a kind of bending wave radiator, like when you drop a stone into water and it spreads out. Yes, but we can also learn from that. However, when I had my first laser, that was, it must have been sometime around before the turn of the millennium. The first thing we realized was that we knew nothing. Because as a developer, you always have your tricks, do this and that, but the correlations are different. That means you really have to start simulating so that you can see which factors play a role there. This is because you modify those specific properties through geometry and not nearly as much through materials. So I always say to those individuals who frequently claim, oh, we have these great materials, now every single aspect of the design is now better. They simply don't know how to properly develop and implement the right complex geometry. So you can design and develop truly wonderful loudspeakers with PP. And with all sorts of different materials, it doesn't have to be anything exotic.
A very exciting topic, and above all, as you just said, you really have to build up an incredible amount of experience over the course of the years.
Yes, that's probably true. The tool itself is of no use. So you can have a thing like this, and if you don't know what the correlations are, then you won't get anywhere with it. Then you just produce nice, colorful pictures for a brochure. But it's very important for us, a standard part of everything we do. So every single item that comes in is tested in this way. That's how you actually get the chassis to a very good level in a relatively short time. And that's also important so that you can then concentrate on the other things that are a bit more complex. Now we're entering the electronics department. Most people think we only make loudspeakers, but that's not the case. We've always made electronics right from the start. And now we have our dear colleague Rainer Fink, not related to me by blood or marriage.
Hi again, Rainer.
Who most people probably know from, I don't know, 35 or perhaps 30 years at Marantz. And he was personally responsible for many, many iconic devices that created the, let's say, legendary Marantz signature sound. We were both dedicated students of Ken Ishiwata, so to speak, and we worked closely with him for many, many decades. Rainer is someone who doesn't just do hardcore technical engineering, but above all, he focuses on the soul of the music. The transition from measuring well to sounding good. Because if something sounds good, it can measure just as well. But something that measures well doesn't necessarily have to sound good. And now for the very first time, really, at least it was the first time for me, but I think for you too, we've finally decided to use a high-quality digital volume control. This is because it can actually become so exceptionally good that it is, in turn, significantly better than a traditional analog volume control. And Rainer came up with a unique method that both measures very well technically and sounds incredibly good to the ear. Because we've already listened to it, and I have to say I was pretty much blown away. Let Rainer tell you about it.
Well, okay, I'll start by approaching it from a different angle because variable outputs have existed on CD players before. And in the past, variable outputs were always digital, and for the most part, they sounded truly awful. On the other hand, there are fewer and fewer good potentiometers. All the manufacturers, like Alps and others, are scaling back their product lines more and more. There are also electronic volume controls, which also range from good to bad. But even the best ones, in terms of noise, signal-to-noise ratio, are only on the level of a good DA converter. So it's therefore a logical step to say, we'll skip this whole analog effort. That was already part of the original design concept for the Sonoro right from the very beginning. We then conducted some deeper research into the matter, and yes, I'm a bit older now, and I can still remember a wide variety of different conference papers from the AES. Specifically, there was one technique known as resolution below the least significant bit. And yes, I spent a significant amount of time working extensively with this particular method and carefully examined the various ways in which you might go about building it around a digital volume control system for audio applications. Yes, as Karl-Heinz already said, we've listened to it. And even if you look at the measurements in detail now, you'll very quickly find that 99% of our industry would say that it's all voodoo now. And you can't hear that anyway. And what we have done now is we wanted to somehow recover and regain what we actually attenuate as a signal up here and gradually lose somewhere in the dynamics. And that is now the distinct green curve here. And then you can see that especially in the range between 20 Hertz and 10 kilohertz, the noise floor is significantly lower at the same signal level. And that becomes even more apparent because you usually look at things like frequency responses logarithmically, when I display it logarithmically, because then you can see that this entire bass mid-range up into the treble range is significantly reduced in the noise floor by about 20 decibels and only at exactly 10 kilohertz. And above that, it evens out, or rather is then identical. So, and yes, here we are, looking at this detailed FFT plot at minus 200 dB, which actually makes these 20 dB fluctuations clearly visible from a professional measurement perspective. But yes, as we were able to determine, also clearly audible.
No, but it was really interesting, and I have to say, for me personally, it's a great joy to be working together like this again and to see what measures well and what sounds good. Because actually, for me, both things are important, very important, and I think for Rainer as well. All right, thanks, Rainer. We don't want to keep you from your work any longer.
A really fascinating input.
Now we come to the next centerpiece here, namely our specialized low reflection room. This is the specific place where we meticulously work on the crossovers. So we measure the performance of every individual driver in the box just as it is, without a crossover and without anything else. So this here, for example, is a near-field measurement on the side. That's something I figured out over the decades, that there's a good spot where you can get a good measurement of the entire frequency response from the port and from the bass driver. And you can see here, for example, it goes down to about 30 hertz. Then that looks good. A measurement like this is always relatively quick. You just press it. Then it goes, then it's done. So this is now finished with all the available chassis types, like so. Depending on how many ways we have. And then we have the simulation program here where they more or less end up. So you can already see here the frequency response looks quite nice. That means we already have a crossover in here. We can take a look at that too. It looks like this. So it's not a 6 dB crossover, but it's also not, let's say, an ultra complicated one. And here a flat frequency response is created first. So, and that's the starting point. Then when we listen, and this is particularly important, and we change something, let's say, I think the mid-range driver is a bit loud. Then I say, okay, I'll put a 2.7 in here. There. And then I see how something changes here in the frequency response. That means you don't just blindly change something, but always check that the measurement still looks just as good as before. And that's more or less how you do the balancing between what you measure and what you hear. I have to change that back now, or there'll be trouble. But you could also, I don't know, take a high-frequency tweeter unit and say, look here, the capacitor value is currently sitting at 6.8. Now let's try to install a 7 microfarad capacitor, or perhaps let's swap it for a 7.5 microfarad component to see how the circuit responds. Bam. And there you can see that this area changes. The funny thing about it is it looks just as smooth as before. I mean, can you say now that it looks crooked? No. But when you hear it, the difference between 7.5 and 6.8 is huge. And that is the point where we find ourselves unable to make progress with the measurement today, because it doesn't look much better or much different. But we always have to have control, because that says, in the past, you always stood in the listening room with a box of components on the floor and made changes. And if you were exceptionally and particularly unlucky back then, you completely messed it up. And then certain speakers came out that could hardly be operated with any standard power amp because they just had a very severe and problematic impedance dip somehow. You can always look at the impedance at the same time. So you can see here, this one now has 3.6, so everything is within the standard range.
The usual values?
Yes. There's an impedance linearization in here, which basically just serves to give the amplifier a reasonable load. So without it, it would look like this. And this one here is a relatively harmless one. We've discovered some that are completely different. But we always build that in as a matter of principle to have a really simple load for the amplifier. But you can also see the transfer function here, that is how the filter runs electrically. I always like to look at that as well. And that's basically how the loudspeakers are created that first go into the listening room. And when they are in the listening room, we always compare, what are we doing here? Is this okay? Can we leave it like this? Yes, I mean, that's the whole secret. It just takes time, depending on how much time you have.
That would actually be my question. How often do you typically make comparisons? What's your experience with that?
It depends on what kind of project you have. If you have one that needs to be finished by tomorrow, you don't have that time. If I have the time, then I like to have many weeks. That means I listen to the speakers, and if I like them, I put them away. Then I take them out again after a while and listen to them once more. Because you can get used to things or get too immersed in a sound, and then you sometimes head in the wrong direction. So that even happens to someone who's been doing this as long as I have. And that's why you need the time to get some distance. And if you have it, then I like to make use of it. Sometimes I come here on the weekend just to listen to a speaker in peace and quiet. And if I then listen to a lot of music and play another record, then the chances are very good that it has turned out to be a quite successful result. Next, let's take a look at our near-field scanner. This is a high-precision klippel device that we've had for some time now. It serves as a valuable addition to our existing anechoic chamber. And in this specific case, you measure all around the speaker directly in the near field and in all dimensions. It runs overnight. It's a relatively long process. but you basically learn the radiation pattern, the speaker's full radiation pattern, and you can gain a significantly deeper understanding here than you ever could in a normal standard anechoic chamber. There aren't many of these things in existence today, primarily because they cost 100,000 euros to construct. But once it is fully up and running, I would say you learn a tremendous amount and can really apply that knowledge effectively.
Very exciting.
Now we've seen how we measure everything. And now we're going into the listening room to hear exactly what we've done. And now here comes the moment of truth. Because with everything we've done, with measuring, with simulating, with this and that, this is where the music has to play. With all the measurement technology, there are many different things that simply cannot be measured in a way that you would say it absolutely has to stay exactly like that. Here, the measurements usually stay very similar or not much different at all. But our human ears, and especially our complex brains, are actually much more sensitive and perceptive than what we can ever do with these standard measuring devices. I don't know if we'll ever find new measurement methods in my lifetime, but I think as long as I still have my ears, I'll continue to use them. Let's play some music. I hope you like it. I always have the music here.
Great.
We can show something else, right?
Exactly.
Now let's put on some real music.
Hip hip it up, hip hip it up, righty yada 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 yo, rub up 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 up, rub up 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 up, rebop bitty bop, rebop bitty bop, righty yada 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 yo.